These are 6.1 notes, part or 6.1b, 6.1 part 2, where we're going to do a little more on exponent properties. So this first section we're going to divide, and we're going to only do this when numbers have the same base, and we're going to subtract the exponents. So here you can see our first problem is x to the 8 over x to the 2. That's going to end up being x to the 6th. So if you wrote this out, this is what it probably looked like when you learned this in pre-L, you might have had x to the 4th over x to the 2nd, and you're going to cancel x over x and x over x again. So because you don't need x over x equals 1. So since you don't need that, you can cancel it. So that's how we end up with x to the 2nd. So on this first problem, we're just going to do x to the 16 minus 10, so x to the 6th. Again, I'm going to show you more work than you need to. I always feel like it's important that I show you where these numbers come from. If you just know that the first one is x6, that's fine. Now, we've got r2 and r to the 1/2. So we're still subtracting. We're just subtracting with a fraction. So I need to make 2 a fraction made of halves. So that's 4 halves. So I'll rewrite this as r. Let's fix that. R to the 4 halves divided by r to the 1/2. And when we divide, we use subtraction. So r to the 3 halves. And we're going to leave improper. Okay, now we've got 1/2 and 1/4, and we need a common denominator. So we're going to turn that into 2/4. So now I have x to the 2/4 divided by x to the 1/4. So that's x to the 1/4. And that's my final answer. I should be boxing these in. Okay, now we're going to apply this rule. We're going to do it to x over x and y over y. So x to the 9 minus 2 would be x7. Y to the 12 minus 5 would also be y7. So final answer on that one. And this one I have x to the 1/2 over x to the 1/4, and y, I'm going to make that y 3 over 3. And I need to write a common denominator for x to the 1/2 divided by x to the 1/4. So I only have to change this 1/2. I'm going to make it 2/4. So x to the 2/4 divided by x to the 1/4. Y to the 3/3 divided by y to the 1/3 equals x to the 1/4. Y to the 2/3, because we subtract those exponents. Now when you have coefficients, you're going to simplify coefficients like a fraction. Nine divided by 3 would be 3 over 1, or 9 over 3 would simplify to 3 over 1. And x to the 1/3, I'm going to turn into 12ths. So that would be 4/12. And then x to the 1/4 would turn into 3/12. So x to the 4/12 over x to the 3/12. So that's going to leave me with 3, and then I'm subtracting 4/12 minus 3/12, x to the 1/12. So 3 times x to the 1/12 is my final answer. Okay, this last one we've got, I want you to think how many elements are in those, or how many pieces are in that base, or not in the base, but in the fraction. So in this one we have numbers, and then we have k's, m's, and n's. So I can already see n squared over n squared. So I'm going to cancel those because something over itself isn't going to change. And now I'm going to take negative 36 and divide it by 9. So that will give me negative 4. And then I need K2, because K7 over K5, and then M10 over M3 will give me M7. So that's my simplified answer. Next, I'm going to have 6 divided by -2, so that's going to give me -3 in the numerator. And this one's really nice because we don't have to convert our fractions. So 6x squared, that 6 over -2 turned into -3 when we simplified. And x6 over x2 makes x4. We subtract those exponents. Y to the 2/3 over y to the 1/3 is y to the 1/3. -12 over -2. So we're going to divide those. That will give me +6. And x7 over x6 is positive x. I'm sorry, x to the 1. And then y to the 3/2 divided by y to the 1/2. Well, that's y to the 2/2, which would be y to the 1. So it's just 6xy. You don't need to write 2 over 2. That's just 1. Okay, in this next section, we're going to find the power of a quotient. So we're going to give each element in the numerator and the denominator the exponent. So here we can start with a squared b cubed divided by c4. So a to the 2, and that gets the exponent of 5. And remember, when we learned this, we might have had a2 to the 5th, which turned into a10. So now b 3 to the 5 divided by c 4 to the 5. So that's a10, b15 divided by c20. Next, x to the 5 times 3, z to the 2/3 times 3, divided by y to the 3rd. Simplified out will give me x to the 15, z, 2/3 times 3 is 6 over 3, which is 2. Whoops, I wrote z to the z. Let's make that z to the 2 divided by y to the 3rd. Okay, next we can simplify first or we can distribute first. It doesn't really matter. I like to simplify when I can. So, 4 over 2 will simplify to be 2. And then I have x to the 1/2 and x to the 3rd. Well, x to the 3rd, if I want to, I'm going to combine that with 1/2. I have to add the exponents because I'm multiplying with the same base. So we need to turn 3x to the 3rd into something over halves. So that's x to the 1/2 and then x to the 6/2. Because if you saw 6/2, you would know that was 3. So that's going to turn into x to the 7/2. And then the 2 went away in the denominator, z squared. And that all gets raised to the 3rd. So 2 cubed, x to the 7/2 times 3 over 1, and then z to the 2 times 3. Okay, and when we simplify that, 2 to the 3rd is 8. x to the 7/2 times 3, well, that's x to the 21 over 2 over z to the 6th. Okay, now in this section, If your base has the same variables in the numerator and or the denominator, simplify inside the parentheses first. So we're going to focus on simplifying first, then distributing the exponent. So I want you to think on this first one. Can you simplify 3 over 4? No. Can you simplify x4 over x? And you can. So I'm going to have 3 over 4, and then I have x cubed in my numerator. And that's all getting raised to the third. So the exponent 3 goes to the 3 in the base, x to the third again, and 4 to the third. Now, we expect pre-algebra students to know cubes between 1 and 10. So 3 cubed I'll write as 27, and I'll need x to the 9th, divided by 4 to the 3rd is 64. And those share no common factors. So that's my final answer. Okay, next I'm going to simplify first. Let's see, 2 over 6 would be 1 over 3. And then I've got A's and B's. So my A value, I have A to the 6 divided by A to the 2nd. So we're just going to subtract there. A4 in the numerator, B2 in the numerator. And that's all going to get raised to the 4th. So I could write this as 1 to the 4th. You're going to remember that that's 1 in a second. A to the 4 times 4. B to the 2 times 4. Divided by 3 to the 4th. So 1 to the 4th is just 1. But I have A to the 16. B to the 8th. And that's all getting divided by 81. 3/4 is probably the only 1 to the 4th besides 2 that I would know, because 3 to the 4th can be made out of 3 squared times 3 squared. So 9 times 9. If you left it as 3 to the 4th, that's fine too. Okay, next one, we have 3 over 7. We cannot simplify that. And x cubed over x to the 1/2. Well, x cubed would be 6/2 divided by x to the 1/2. So that's x to the 5/2 in the numerator. And here I have y over y to the 3rd. So y times y times y. So we can cancel those y's, and there's 2 extra in the denominator. Y squared. And we're getting raised to the 4th. So every piece inside there is getting raised to the 4th. 3 to the 4th, x to the 5/2 times 4 over 1, divided by 7 to the 4th, y to the 2 times 4. So 81, x to the 20 divided by 2, over 7 to the 4th, y to the 8th. And finally, the last thing is to just simplify that fractional exponent since it does simplify. So 81 x10 divided by 7 to the 4th, y to the 8th. In this last section, we're going to have a numerator raised to a fraction and a denominator. I'm sorry, a numerator raised to an exponent and the denominator raised to the exponent. So the exponent in the numerator goes to the numerator, exponent in the denominator goes to the denominator, and then we're going to simplify at the end. So on this first example, x to the 2 to the 3 would turn into x to the 6th. In the denominator, we're going to get x to the 6 times 5, so x 30. You could have seen this in pre-algebra. So we have this 1 as a multiplier. So I'm going to leave 1 in the numerator. And then if we canceled 6 over 30 x's, I would have 24 left. So on this first one, my answer is 1 over x to the 24. Next, we've got everything in the numerator gets a 2. So 3 squared, a to the 4 times 2, b to the 3 times 2, divided by 12 to the 6th, a to the 2 times 6th, b to the 5 times 6. And now I'll simplify. 3 squared is 9. A8, B6, divided by 12 to the 6th, no idea what that is. A to the 12, B to the 30. Okay, so my A's stick together, my B's stick together, even my whole numbers stick together. So we're going to say, I'm going to leave my A over 120, or 12 to the 6th. And then I have a to the 8th over a to the 12th. So if we canceled, we'd have nothing in the numerator, but since we have a 9, we can leave it there. And when we cancel it out, there's 4 A's left in the bottom and 24 B's left in the bottom. Okay, this very last one, we're going to simplify first. So we're going to do the 4 over 2. That's going to give me 2 in the numerator. And then x5 over x9. Since there's extra x's, we're going to put x to the 4 in the denominator. And then we've got y to the 4 over y. I think I'm doing this one wrong now that I think about it. Let's try this again. Okay, my bad. Sorry, guys. 4 to the 3rd, x to the 5 times 3, y to the 4 times 3. Divided by 2 squared, x to the 9 times 2, y to the 2. Okay, now, I know 4/3 is 64. I know 2 squared is 4. Okay, numerator x's. I'm going to get x to the 15 and y to the 12 divided by x to the 18, y to the 2. So we can simplify 64 divided by 4. Let's see. How many times is 4 going to 64? 1. So 16. And then look at your x's. Decide where you have more. There's more in the denominator. So x cubed and y10 left over in the denominator. And that is the end of those notes. They weren't that long, but they weren't